Good evening. Good evening, ladies. Good evening, ladies. How are we doing today? How was our day? The network is really wonderful. Let's not say it's bad. It's wonderful. Hello, so how many people do we have here currently? Good evening, everyone. Hmm. Prega, if I'm correct, this is my first time seeing you here. Prega, this is your first time, if I'm correct. Good evening, Mohammed. And network is. Let's wait for about 3 minutes extra. Tejiri, good evening. But as the influence, I didn't see that. Oh, you've always been here, sorry. So let's give others some minutes to join. Network. Okay. Let's give others some minutes to join before we dive deep. Whew. Good evening, everyone. Good evening, everyone. How was your day? How are you doing? Good evening, Ajibo. So in the next 2 minutes, we are going to start. Good evening, Olushola. So guys, sit tight, relax, and let's start this. So if you would like us to proceed and you're ready, can I get a fly? Can I get a fly from us? There are some people I've not seen, but I guess they are going to join us. Can I get a fly? If you can hear me and you like us. Okay, 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 okay. So today's class is going to be very interesting. Um, I would like us to pay close attention. You understand? Trust me, we are going to enjoy today's class. So I'm ready. So let's dive deep into today's topic. So we're talking about AWS data services. So right since on Monday we've been talking about databases. We spoke about SQL database and NoSQL database. And who can tell me an example of a NoSQL database in the Amazon has? You can tell me an example of a NoSQL database. So I'd like someone to just tell me an example of a NoSQL database. Yeah, Amazon DynamoDB. Yes, DynamoDB. Exactly. So now let's talk about data services. So the the first one, Amazon Redshift, is about data warehouse. Let me just give us some hints before we dive into the slides, because today's slides is about these three services. In fact, I compressed about. I just tried to make the slides about 50 or so. So you understand, about 50 slides. I don't want to make it much, so I just quickly just made it around 50. So because these services we have to do justice today. So the first one, Amazon Redshift, is a data warehouse. The second one, EMR. When you think of EMR, when you hear EMR, think of big data. Do you understand? Yeah, Amazon Dynamo DB, and the other one is Amazon QuickSight. Think visualization. That's the first thing that should come to your mind when you hear of Amazon QuickSight. So I can't see our faces. For some reason, the network fat, I don't know. Maybe I'm going to switch to MTN, but I didn't quickly set up my MTN router before the class started. So I'll do that maybe by head so I can see our faces. Our wonderful and beautiful faces. So let's move on. So this is an introduction. So I'm just going to give us as much as we need for this level, and I'll go a bit deep just so we could understand. But trust me, I've provided everything you need to know about each of these services here. So let's go. So let's first of all talk about data warehouse. Let's talk about data warehouse. When talking about Amazon Redshift, we are relating to the data warehouse. Before we go deep into Amazon Redshift, let's first of all understand what a data warehouse is. So, yeah, anybody that can just tell me, everybody knows what a warehouse is. So, just just put data in front of the warehouse. You understand? You get it. So, if we don't get it, let's move on. So a data warehouse can be thought as a large storage space that holds a lot of information from various sources within an organization. So it's very key that we understand it. So let's look at it. It's a central repository. Imagine a big library where all the books from different genres like history, science, and the rest of them are collected in one place. So a data warehouse collects data from various sources. You get it? It collects where data is. So, Devina, your sense is too much. So, it collects data so like sales, marketing, finance into one central location. And there's something we also call data lake. But in the previous this thing we'll be discussing about it. Discussing about it. They're kind of similar, but they do different things. So the other one is structured data. Data is organized in a way that makes it easy to find and analyze. So we said it holds a lot of data, a lot of information. It's connected various sources from various sources. Data comes into the data warehouse from various sources. So the data is well organized in such a way that it makes it easy for you to analyze such a large data. So unlike a regular database that handles daily transaction, like a bank, so a data warehouse is designed for reading and analyzing somebody say large amounts of data. So there's also a historical data. A data warehouse stores historical data, which means it keeps record over the time. You understand? So historical data cannot be stored in a database, of course, So where is the data going to go? Where are these historical data going to go? They're going to go into a place called a data warehouse. So also it supports analysis. So people like data analysis or business intelligence teams, any data analyst here. So data analysts that are here, all the services we are talking about today, some of you are going to be very, very familiar with it. So if can I get an emoji, any kind of emoji, but a nice one? If you're a data analyst here, can I just get can I see your hands, maybe a hand emoji or any kind of emoji? Any data analyst here? Any data analyst here? Oh, no, I'm not saying anything. This network is not good though. There be AK. I don't think you posted anything here. Okay, so if there's none, wait. Are we there? Are we there? Are we there? Can somebody just like, I want to know because we're about 32 here that I can see online. Can I get some smiling emoji? Can I get some smiling emoji? Oh, it's like our day. Our day was very wonderful. No, I want emoji. I want emoji. I want emoji. Okay. Everywhere just suddenly seems quiet. It's like I'm hearing myself and it's kind of so much. Okay. Ehen. Yes. Okay. I'm saying, okay. Come on, smile. Ehen. We're about 32 here. I'll press pause. Oh. I'll press pause. Oh. We're about 32 here and I'm just getting about roughly almost 10 people responding. Okay, the network. Don't mind the network. Okay. The network is not smiling. Don't mind the network. But whether the network smiles or not, we must surely smile. So now let's continue. So supports analysis. People like data analysts or business intelligence team use data warehouse to run complex queries and generate reports. So let's fly. I can't even see Levina, but let's go on. Let's go on. So, for example, they might want to analyze sales trends over the last year or compare the performance of different products. Let's move. So let's look at an analogy. An eye. Some of us, when we're talking about data warehouse, you understand, you can see what is data warehouse? What as in how when there's a storage, how does data warehouse come to play? When there's a storage, you understand what's the use? At least I can still understand the difference between a data warehouse and a database. Or how to differentiate between a data warehouse and a storage. Because remember, we talked about Amazon history. Yes, we talked about that guy that is an object storage. So now let's look at an analogy. Let's take a library, for example. A data warehouse is like a library where all the books, data from various genres, like I said, sources are organized and categorized. So just as a library allows you to find and analyze information across many subjects, historical data, the data warehouse enables you to run complex queries and generate reports based on aggregated data from multiple sources. Hmm? You get it's like a library, well arranged, different types of books. You get it now. So now storage. Sorry for using a garage. So storage is like a garage where you keep various items, data, without a specific organization. Now, you might store tools of old furnitures and seasonal decorations all in one place. So while it's convenient to have these items accessible, you might not have a structured way to find them quickly. You get the idea now? So similarly, storage solutions like S3 hold data in various formats without a predefined structure, serving as a place to store anything from documents to images. So now there is nobody, you understand, in this place that won't say, you understand, you have a place, not necessarily a room or maybe one space where you just throw things that are not not that you are not using, you are no longer using them like that to, but just say, let me just keep them. You understand? Just in case I might need them. You understand? You store them like, I'm just saying, like brush, you get it, like shoes, like clothes, ladies, you know, maybe you just bought one bag and you've used the bag and the bag still looks fine, but you don't want to keep it amongst your new bag, so you just find one place to put it. That place that you put it, just think of it like a storage. You get it? So I believe we understand there's a clear difference between data warehouse now and a storage. Hmm? So let's proceed. So now, speaking of data warehouse, there's a service called Amazon Redshift. I know the name don't sound warehouse-ish, but that's the name Amazon calls it. So we just have to flow with it. So let's talk about Amazon Redshift. Now, um, Amazon Redshift is a fast, fully managed petabyte scale data warehouse service that makes simple and cost effective with that ladies in check. That slide there is kind of blocking what is there. Let me see if I can remember what. So service that makes it simple, okay, that makes it simple and cost effective to efficiently analyze all your data using your existing business intelligence to take note of that. So it is optimized for data sets ranging from a few hundred gigabytes to a petabyte or more and cost less than $1,000 per terabyte per year. Imagine that. So it tends the cost of most traditional data warehouse. I'm coming. Okay. So before I even go deep into data warehouse, before the cloud, like I always like going back just so we can really understand. Just for example, every one of us here, there's nobody here that won't say he or she has used this phone that is saying, I don't want to use the Yoruba name, that is paper that want me like our Nokia 3310, all these old phones. Ah, there's nobody that have not used phones like that. There's nobody that will say my first phone was an iPhone or was a Samsung. So you understand? So something happened, you understand, as the tech began to grow, as people became wiser, you understand, they thought of it. Things can be better, you understand, things can be advanced. So if, for example, the phone that we were using in those days, you understand, was able to evolve, you understand, and we get to the area where now we have phones that have good camera. You understand? The same thing with Amazon Redshift. Yes, that's true. That's true. Button phones. So now everybody's using screen touch. And imagine if there was tap swap then and we're using button. So let's don't even go there. Let's don't let me change it. So yes, Motorola, Nokia 310. So the same thing. There is why I'm saying this is this. There was always an old way of doing things, or let me say there's always an old version of something. Then when it's being updated, it's being how will I put it? Uh, People come together, they brainstorm to see how it's going, how it can be better. You understand? So they came up with something even more better. So think of it the same way as cloud. There was on-premise where people usually manage their data and their servers and the rest of them by themselves, spend a lot of money, and the rest of them, yes, open and close phones. There's nothing like open. You guys are old though. You guys are old though. Wow, not old like that. So you understand what I'm saying. So before there was data warehouse, not that there was no data warehouse, because I'd like us to understand the changes that Amazon Redshift brought. You understand? Because as a cloud technician or as a cloud engineer or as cloud anything, one thing you must learn to understand is this: you should be able to convince either your client or your customer that why should they use Amazon Redshift? Why should they come to the cloud? So having a deep understanding of first this cloud practitioner level that we are covering, this is the main role of a cloud practitioner level. You should be able to convince your customer, you understand, why they need to move to the cloud. So I know I'm taking time, I've deviated away from what we are doing, but I don't really deviate. I just want us to understand. So if you notice, we are talking about traditional technologies before we started talking about um, cloud cloud-based technologies. It's very good for us to understand them. Not that cloud just came into being. There was something actually happening before. Hope we get it. So let's move. Let's move. So so a data warehouse by now, you understand that Amazon Redshift is also a data warehouse. But then Amazon Redshift is much more better. Like said, is a tenth is a petabyte data. You get sorry, it is optimized for data sets ranging from a few hundred gigabytes to a petabyte or more, and cost less than $1,000 per terabyte per year. So that's a tenth the cost of most traditional data warehousing solutions. So now let's say Amazon also uses SQL to analyze structured and semi-structured data. Now take note of that, both structured and semi-structured data across data warehouses. You understand? Operational databases and data lakes. That's spoke about data lakes, so we won't cover it. So using AWS designed hardware and machine learning to deliver the best price performance at any scale. So breakthrough data silos and gain real-time predictive insights on all your data in a few clicks with no data movement or data transformation. So you gain up to 3 times better price performance than any other cloud data warehouse. So based on research, Amazon Redshift is one of the, in fact, is the best data warehouse as at right now. You understand? Amazon Redshift, S3, and I guess there's one other service too, like that. So compared to other clouds, apart from the fact that AWS is known worldwide, but there are some of their services that are far much more better, and Amazon Aurora too. So we're not really going to go deep into those things now. So let's move on. So get data insight in seconds without worrying about infrastructure management with a secure and reliable analytics service. So let's fly. So challenges. So I'd like us to look at the challenges of traditional data warehousing and Amazon Redshift solutions. So we're just going to look at a few of them. What these are in fact the key things when it comes to the cloud: scalability, performance, cost efficiency, ease of use and management. You understand? We'll soon get to the age where now that people no longer, since we are in the AI age now, people no longer want to brush their teeth by themselves. Just get me a robot to brush my teeth and the rest of them. So let's move back and just see each and every one. One of them, let's see them one by one. So scalability, we all know. So the problem, traditional data warehouses often struggles to scale efficiently. This has always been the problem with growing data volumes. As organizations accumulated more data, scaling up hardware could be expensive and time consuming. So the solution now, Amazon Redshift provide a scalable architecture. We're going to see the architecture that allows users to easily add or remove compute nodes. We'll see what compute nodes are, enabling them to handle petabytes of data without significant overhead. So let's look at the performance. Traditional data warehouses could be slow in processing complex queries, especially when dealing with large data sets, leading to delays in generating insight. And since Redshift uses a columnar storage format and optimizes the execution of queries with techniques like parallel processing, result caching, and data compression, resulting in significantly faster query performance. So I don't want to go through all the slides. I don't want to go through each and every one of them. I just want us to have it. So let's cost efficiency, ease of use and management, and that's all. So let's proceed. So now let's understand the architecture of Amazon Redshift. Now, there are no AWS services included here. It's just the architecture. So what goes on? It's like what goes on in the head of Amazon Redshift. You understand? If scientists look into our head, they can draw an architectural diagram of how our brain works. You understand how the cerebrum, blah blah, those of us that are biology, how it works, how frequencies are being sent, how the brain communicates with the eye. You understand? So this is just everything that's going on in Amazon Redshift. This is all Amazon Redshift. I hope you understand what I'm saying. Unlike other architectural diagram, will be showing us that links that integrate with other AWS services, you understand, to build an application. But this is just Amazon Redshift. What actually happens? What actually happens? Hmm? So at this moment, if you like me to fly, can I get a fly? CSF flow. What's CSF flow? So sorry about that. Can I get a fly, please? Can I just get a fly? I need our fly, please. Yes. Please send your flight so I can proceed. Okay, yes, thank you. Thank you. Okay. I want to know those that are following us. Yes. Hope I didn't drop us along the way. Has come again. Debbie, you're saying I should come again? Oh no. Come again. What's the issue? Debbie, what's the issue? And Debbie, what's the issue? Sorry, what's the issue? What's the issue? What's the problem? Debbie, is it that you didn't hear what I said, or you want me to explain something again? This slide, oh, don't worry. In the next slide, I'm going to explain each and every one of them. Yes, don't worry. So we're going to explain. So this is an architectural diagram of what is going on within Amazon Redshift. We say it's a data warehouse. It's not just a data warehouse where you just go and be dumping everything. Not like what are they calling these people? Oh. What are they calling these people? Is it last man? No, it's not last man now. Some of us are in Lagos, in Nigeria. What are they called? What they always dump debt? Where they always dump debt, that the truck will carry it and go and dump it. Ah, Mr. Damilola, yeah, too much. Yes, low man. So, data warehouse, because when I say data warehouse, yes, low man, don't mind me. So many things I in this head. So don't think of a data warehouse just like where you understand all this last mile truck carries the goods, carry the data and go and dump it in one place. No, no. There's actually some processing going on before it gets there. Because mind you, we all know at the forefront there's an application. You understand? There's always an application that wants to get this data, that is even storing the data there. You understand? That's going to make use of this data. Hope we get it. We get it. So now, just have a look at it. This architectural diagram. You can zoom it. You can take a zoom at it. You understand? You can zoom it. You can zoom it. You can go close to it because I'll be explaining each and every one of them. And trust me, it's going to be very interesting. So many of us know book. Yes, Levina, Lisbeth, Lovett, Lovett, Levina. Wow, Lisbeth, Lovett, Levina. I've seen Levina before. But Lisbeth and Lovett. That name sounds familiar. I mean, sorry, I say familiar. I've not. This is the first time seeing you people here. So can we move on? So let's move on and explain each and every one of these. Will I say components? Yeah. Now, so we know the first one is a client application. Now let's talk about this guy first. So the client application, the client app of Amazon Redshift interacts using two drivers. Now, hope it's not the drivers we are thinking. You understand? So it uses two drivers. Now, because this logo has covered it, what is this? JDBC and the ODBC. These are the two drivers it uses, and we must have seen it here. You see, there are two drivers. You don't see them, but there's a driver there. So this is another driver. This is the first one, and this is the second one. So let's see and understand them one by one. So the JDBC, I'm not going to call in Java database connectivity. No, I don't do that. You people, you know by now. So the JDBC, you understand, the Amazon Redshift service uses JDBC using the JDBC can monitor the connection from the other client application. So the leader node can have a check on the client application using the JDBC connection. So this has to be an interaction between the leader nodes and the client application. So it sends or it communicates to the leader nodes using the JDBC. Now, the ODBC is allowed the user directly from any app to interact with live data of Amazon Redshift. Now, it has a direct connectivity, direct access of the apps, as well as the leader node can get information from the compute nodes. Let me make this very, very simple. The client applications is able to have access through this leader node using the JDBC. Now, when it wants to receive information back or receives the data back or whatsoever it has sent a request for, it does not need to this JDBC again. You understand? It's through this ODBC. Now, this one, sorry, the slide I started moving on again. So now, this is Java database connectivity. This one is an open database connectivity. Why this one monitors the connection from the client application, so the leader node can have a check on the client application using this connection, that's the JDBC. This other one allows the users directly from any app to interact with the live data that is already in Amazon Redshift. It has a direct connectivity, direct access of the apps, as well as the leader nodes can get information from the compute nodes. If you would like me to fly, tell me. If you are not getting it, let me come again. If you like me to fly, can I get a fly? It's very simple. That's why I had to come up with that architectural diagram. If you didn't get the client application, you cannot fly. Okay. Now, what we need to know here is how does the client application even interact with this? Okay, don't worry. Let me come again. What's going on? Oh. Okay, so remember I said, Bootcamp, don't worry, I'm coming again. 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 Don't worry, I'll repeat again. Now, client applications, they won't just enter inside the data warehouse. They need something to use as a connectivity to the cluster. Now, take note that this down here is a data warehouse cluster. Now, a cluster, before we even get to this, is a combination of several compute nodes. You understand? The coming together of 2, 3, 4, 5, 6, 7, 8, 9, 10 compute nodes makes up a cluster. They are literally EC2 instances. Don't tell AWS I told you. So they are literally EC2 instances. Those compute nodes are EC2 instances. Hope we get it now. Like I told you on Monday, when you hear of compute nodes, even when they say serverless, is actually EC2 instance. Every senior tech knows that. So even these leader nodes and these compute nodes and the rest of them, all of them are EC2 instances. Hope we get it now. You get it? Yeah. So now let's proceed now. So how does the client applications communicate with the cluster? to the data warehouse cluster. So it does this using the JDBC. So that is how it communicates with the data or with the data in the cluster. Now, let me go back to this slide. So let's go over it again. So using JDBC can monitor the connections from other client applications. So this leader node can have a check on the client's application using the JDBC connection. Let me come again. The JDBC, now, Redshift service using a JDBC, it can monitor the connections from other clients, so the leader node can have a check on the client's application using the JDBC connections. Now, the open database connectivity. So this allows the users directly from any app to interact with live data of Amazon Redshift. Yes, don't worry. This is it. This is it. This is how but don't worry, just take your time. Like I told you, some things like when you just eat eba, it's not immediately digest. It can take 1, 2, 3 hours. Especially all those eba, those gari eba. Those ones can take years. I say years. It can take 2 to 3 hours. So what I want to just say here that we need to understand. Now, this arrow connects. This arrow is, think of it that it's sending data or communicating with the data with the leader node. Whatsoever information or the compute node, after processing everything and the rest of them, guys, okay, let's take the fufu and everything away. Let's wave it off. So are we here now? If you want me to proceed now, can I get a fly? Can I get a fly? Can I get a fly? Can I get a fly so I can go over this again? Okay. So the two of them, JDBC and ODBC, are connectivities. Now, they interact with the leader nodes. Think of the JDBC like it interacts with the client application and kind of send information to the leader nodes. Let me make it very simple. Now, the ODBC sends information back from the leader nodes back to the client application. Very simple. This one interacts with the leader nodes, while this one sends information that comes or data that has been processed from these compute nodes back to the client application. As simple as that. Let's proceed. Now, let's look at the leader nodes. The leader nodes manages the interaction between the client application and the compute node. Think of it as a middleman now. Hmm. It went out. Don't worry. Let's just leave it like that. Sometimes technical terms are not the best solutions. So let's just leave it like that. I believe we understand now. Okay. Okay. So let's proceed. So now let's talk about the leader nodes. So now the leader node manages the interaction between the client application and the compute nodes. This guy is like the middleman. You understand? It's the one that does it doesn't process, neither does it store data. Take note, it doesn't process the data the leader knows, neither does it store data. It does not. It serves as a middleman and develops design, does not store the data. You understand? Think of it as it's a middleman. So it's a bridge, like you understand, it's the one that makes life easier between the client application and the compute nodes. As you can see the compute nodes here, you can see these guys, and you can see the leader node. So let's proceed now. The compute nodes, they are basically kind of our databases, which does the processing. Now, these guys, sorry, I don't know why am I using it? These guys are the ones that are the real databases. These ones are the ones that stores the data and processes the data. They store this data and they process the data. So you see, we have compute node 1 to compute node n. That means as the data is coming, sorry, don't mind me. As the data is coming, I remember Amazon Redshift is serverless and it also has a provision mode, sorry. So I didn't want to make the slide long, so I didn't put it there. So you can choose to set things by yourself, or you can choose not to set things by yourself to make life easier. I mean, why will I do it when I know something is serverless? When it can do all these things, why do I have to get my hands dirty? So you understand. So, but it's left to you. Some people can say, "Let me do the work." You understand? And you decide to set all those things. So one thing you need to know, you see the compute node 1 to compute node n. That means, we said it's one of the benefits of Amazon Redshift compared to other traditional database warehouse is that it scales till infinity. It just scales. You get it now. So that's why we say n. Now let's proceed. So like I said, so now this cluster, these are a set of compute resources which are called as nodes. And this gathers into a group which we call it as a data warehouse cluster. So you can have a compute node starting from 1, like I said, to n numbers of nodes. That's why we say that Redshift is a scalable service because we require. So you can choose to do this, like I said, manually, or it just does it for you. So let's move on now. Can I fly? I say enter. This shouldn't take seconds to enter. You understand? So just let me know if you'd like me to phrase everything again. Just let me know if you'd like me to phrase everything again. Or if you'd like me to fly, can I get a fly? Okay. Don't worry. If you go back to these slides and you want to try and understand the technical aspect of it, because sometimes some people like myself, You understand? And many other people. Sometimes technical things is technical. Technical things are technical terms because they are technical. So sometimes you have to pause meets time and also cover so much. But once you get your hands on these slides, you can just yes. Let me tell. How many of us we are using ChatGPT? How many of us know Poe? How many of us know Poe? If you know Poe, can I get a yes? Good evening, everyone. I'm really struggling with network today. Don't worry. Comfort. Don't worry. Some things I and my colleague are going to share some things with us. You've heard of it. Everybody knows. That's what I'm saying. It's not polo. It's not polo. It's not polo. Which pole now? Now it's not pole. I say pole. See my mouth. Pole. Pole. Now let me quickly write. I can let me POE. So that's me typing it there. Pole. Yeah, pole. So guys, let me tell you something. Pole. Trust me, if you start using pole, he'll come back to me and come and give you share your testimonies. But when you're coming back, make sure you come with your tithes. Make sure you come with you get it. So Poe is to me, Poe is far more better than ChatGPT. If you don't have money to pay for the ChatGPT Plus or to whatever, so just use Poe. So if you want to get access to it, just do Poe.com. And trust me, so why am I saying this? It's good for us to do research. You understand? It's good for us to do research. So on your own, you see, like I've tried to allow this JDBC and this ODBC, these technical terms, and they are not entering. So on your own, you can just go and do your research by yourself and say, ChatGPT or Poe, can you explain to me in a more simpler terms what JDBC means or and ODBC? You get it now. So trust me, all those things, this search and every other thing is going to help you. And you even understand it better. So that way it will digest well. So let's proceed now. Let's proceed. So I spelled it Poe, 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 Poe. No. I didn't say poor. I didn't say poor. I said Poe. Levina. Levina. I said Poe. 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 Yes. E for egg. Yeah. So most of us that are in the chat, see now, I've spelled it now. Just scroll back up. So we'll soon be going for break. I want us to cover, at least let's cover Redshift because there's no knowledge check today. So now that reminds me, before we even go for break, our guy at the top, that's in our organizers, they said we should pass this information across to you, this information is crucial. Trust me. I would like every one of us to please make sure you are following suitly. So make sure you're on the LMS platform because trust me, we are going to drop in some updates there, some things that are really going to help us. So I don't want to spill everything out here. So those of us that know they've been following us from day one, and those of us that know what these guys are really good, and these guys have really been doing wonders. You understand the way they explain, the way they teach. They just make me love cloud computing. They actually left one uh, class and they came here. You're welcome. So make sure you are part of the LMS class here. That's in person of Mr. Damilola and Mr. Ejiri. You must have seen them popping in there. So get across to them. You can't hear me, eh? You can't hear me. No way. Please repeat yourself, sir. We missed some of the things you said. My Jesus. I just want to give us a little breakdown of OLAP. You understand? Amazon Redshift use this technology. So it stands for online and analytical processing. So this is a category of software technologies that enables analysts, managers, and executives to gain insight into data through fast, consistent, interactive access in a variety of ways. In a variety of ways. Sorry. So let's proceed. So it is designed for complex queries. Like we said, the data warehouse it has to do with it has to do with large data sets. So you're gonna say this designed for this is designed for complex queries and enables users to explore data from multiple perspectives such as time, geography, or product categories. So now let's see a simple breakdown. Sorry. So let's say so purpose of OLAP is designed for complex queries and data analysis rather than transaction processing. You understand? Rather than database. I believe you understand now. So it helps in understanding data trends, pattern, and relationships. So talk about the data structure. So OLAP system often use multidimensional data model, allowing users to view data from various perspectives, dimensions, such as time, such as time, ha, the break. Let's take a break. So you mean that I've been talking since and nobody, oh my Jesus. Let's take a break. Let's take a break. Let's take a break. Sorry about that. I'll switch to another line now. Let's take a break. Let's take a break. Let's mark our attendance. Network can be something else. Let's take a break now. Our attendance is in the description. So let's fill it and come back. So I'm so sorry for uh, taking so much time. Sorry, I just had to switch routers. I believe we're taking our attendance now. So we had that time to really sit back and, you understand, take it now. So let's move on. So we have had the OLAP. So let's proceed. We say OLAP stand for Online Analytical Processing. It's a category of software technology that enables analysts, managers, and executives to gain insight into data through fast, consistent, interactive access in varieties of ways. So it is designed for complex queries and enables users to explore data from multiple perspectives. So let's look at the breakdown. Uh, let's look at the breakdown. So Purpose OLAP is designed for complex queries and data analysis rather than transaction processing, rather than OLTP. So it helps in understanding data trends, patterns, and relationships. So the data is structure. OLAP system often use multidimensional data model, allowing users to view data from various perspective dimensions such as time, geography, or product categories. So businesses use OLAP for reporting, data mining, budgeting, forecasting, and financial analysis. So let's move on. So Amazon Redshift is an OLAP database. By now we understand what OLAP means. So that enables efficient data analysis and reporting. So if you guys would like me to fly, I hope we've not over relaxed ourselves. Oh. I hope we can I get a fly? Hope we've not over relaxed ourselves. Oh. Oh yeah. So the information I'm trying to say is this, the crucial information is this, that we should all make sure there's a big update that is coming. You understand? I don't want to spill it here, but I want every one of us to key into our LMS platform and the Telegram. Trust me, you don't want to miss on this. Trust me, because our guys at the top, they are trying to do some things, and they need those that have been committed and are following every rules and regulations and are consistent. So these are the people that are going to partake in this national cake that's going to be passed across to everybody, that they have their names and the rest and every other thing related to them. So do well to make sure you are um, following suit, and you can reach out to Mr. Idiri and Mr. Dami, you understand, so they can give you let you understand how things are going. So now let's proceed. I believe you all understand. So can I get a fly now? Can I get a fly? Can I get a fly? Can I get a fly? Hey, we have to leave here before 9. Oh. Hey, can I get, so let me quickly proceed. I've seen a new person get cheap. Let's do. So let's see, how does Amazon Redshift use OLAP? So it's an online database that enables efficient data analysis and reporting. So here's how it utilizes OLAP principles. So column here, columnar storage. So Redshift stores data in a columnar format, which spreads up data retrieval for analytical queries. So because the data there's a large sum of data, so columnar storage is one of the best way in order for you to uh, have access to data or to understand the data. So Massive parallel processing, it distributes query workloads across multiple nodes. You understand? Enhances performance for large data set. So all this we can just, I decided to pull all this in order for us to have a deep study. You understand? So that's why I decided to pull all this. So this is how Redshift use OLAP. You understand? So in summary, Amazon Redshift leverages OLAP's principle through columnar storage and parallel processing. So it makes it an effective solution for fast and efficient data analysis. So let's proceed. Now, let's quickly talk about, I know many of us we are not new to when we say columnar storage, we all understand, but let's still talk about it. And I'm not really going to touch everything. I'm just going to give us analogies so we can understand. So think of a column storage is a method of organizing data in databases. So it's a method of organizing data in databases where data is stored in column rather than rows. So this approach is especially useful for analytical queries. You get it now. So analogies, for example, you can think of the library books, you can think of spreadsheets. So you get, so think of the journeys as the columns instead of by individual books. That's raw. So you get, so if you want to find all books in the science fiction genre, you can quickly go to that section and see all related titles at once. So rather than going through every book on the shelf. So also spreadsheet is another analogy that I can think of it as a spreadsheet. So benefits, so faster queries, efficient compressing. So the data in the same column often has similar values, allowing for better compression and storage efficiency. So let's proceed. Let's proceed. So now let's take a look at how a columnar storage is. So stores data together as columns instead of rows. So with this definition, I'm hope I'm able to with this, sorry, with this how will I put it now? So with this that we can see on our screen, I hope I'm able to convince us. So I don't want us to go too deep into things. So with this, we can already understand when we're talking about columnar storage. Uh, oh, yeah, too much. Just like I said, those of us that are data analysis, we understand what I'm saying. Yes, just like I said. So, can I fly from here? Can I get a fly? Can I get a fly? Or am I too fast? So can I get a fly from us? So I can proceed to the next stage. Okay. Yeah. Yeah. It's like I'm also seeing Chidera first time. I don't want to get to know ourselves later. Okay. So let's fly. What is going on? Okay, let's fly. Now, there's something I want to discuss with us. It's just for us to have an overview of what it is. So that's Redshift spectrum. Somebody say Redshift spectrum. Now, receive the grace of not coming late again. Latina. You can always go back. Now, spectrum. Think of spectrum as a tool. You understand? Now, it queries data that is already in S3 without loading it. Now, let me quickly explain this architectural diagram for us. So remember we said a Redshift cluster consists of nodes, compute nodes, you get it. There's a leader node. So imagine we already have a data. Yes, yes. Moment, let's say uh, Redshift spectrum. So let's assume you have data already in Amazon S3, and you want to make use of a tool in AWS. Let me quickly make it very simple. So with Amazon Spectrum, you can analyze the data in that S3 bucket. So here's how it works. You see, we have the query. So you make a query. Oh, so select from, so the select can be anything. Select from S3, the bucket. You understand? So you can see the JDBC and the ODBC connector. Yeah, in fact, it's even more than this. It's more than this. I didn't get to talk about there's one other aspect, how it's scalable, how it's easy, the snapshot and every other thing. So that's why I said virtually all the AWS services are broad. Yes, so this, since it does the cloud operation level, and we don't really need to know deep really about it. So, but trust me, it's very interesting. My colleagues here too can tell it's very interesting. It's sweet once you get to understand. So this is just an overview of Amazon Redshift. This guy is deep. So let's proceed now. So let me just explain the architectural diagram. So take note, data that is already in Amazon Redshift. And I'm going to just tell us what we need to know about Redshift Spectrum. So you can see the Redshift Spectrum nodes that are here, compute nodes rather. So data is already here in Amazon REST in S3. You want to query this data, and in order for you to be able to, you want to query data use through Amazon Redshift, leveraging on Redshift Spectrum. You understand? But make sure the data is already in Amazon S3 buckets first. So you must have a Redshift cluster available to start the query. So the query is then submitted to thousands of Amazon Redshift uh, Spectrum nodes. So the more the queries are being done, you understand, the more the queries that are coming, you understand, the more the nodes of the spreadsheet get Redshift Spectrum get more. So you can see n, anytime you see n, just know it goes on. So from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you get to infinity. So you understand. As long as you if you continue making queries, there is no level at which you get to that all of a sudden you say you run out of nodes or compute nodes. No. It goes 1, 2, 3, 4, 5, 6, 7, 8, 2, 3, 4, 5, 6, 7, 8, like that. So you understand, it goes, the compute nodes just continue expanding. So you understand. So you can make query using Amazon Redshift. Take note, data is already in the S3 bucket. So you understand. So let's proceed. That's what you just need to know about Amazon Redshift Spectrum. So let's fly. Now let's talk about really cool. So let's move on. Let's talk about another guy now. Amazon Elastic Map Reduce. Now, this has to do with big data. This one has to do with big data. Some people don't get it. Hope you are not sleeping. I didn't even see Onoa, Anoluwa. What's that name again? No? There are some patients, but maybe they are following. Maybe they are trying to digest what is being given them tonight. But don't worry. So let's talk about EMR. Let's talk about EMR. Now, Amazon EMR is a cloud service that simplifies big data processing. This has to do with big data. It has to do with big data. So using open source tools like Apache Hadoop and Spark now, these are open source tools for big data. So it enables you to process large data sets quickly and cost effectively. So Amazon EMR is a powerful tool for processing large data sets in the cloud. So it's flexible and integrates with AWS services. Yes, Oluwa. Yeah, with us in spirit. They're trying to digest it. I know. So this lecture is kind of it can be hard to swallow. But don't worry, I believe we are good. So it's flexible, it's flexibility and integration with AWS services makes it an excellent choice for big data projects. So now let's talk about what big data is. So big data refers to extremely large data sets that are difficult to process using traditional data processing tools. So EMR helps manage and analyze these data sets. We get it now. So what we just need to know is when we hear of EMR, think of big data set. So it leverages open source tools like Apache, Hadoop, and Spark. Hmm? So let's see the core components of EMR. So like I said, all this big data, all this warehouse data, large data set, they are nodes, they are compute nodes. You understand? Like I said, clusters. A cluster of Amazon EC2 instances that work together to process this large data set. So we also have the master node, we have the core nodes, and we have the task node. But we're not going to go deep into all these things. Just the master node coordinates the cluster and manages the job flow. In fact, what we need to just know, to be sincere, just know what EMR is, and the next AWS service I'm going to be talking about. Okay, so this is what we need to know, even at solution architect level. For when I did the exam, and many other of my friends that did the exam, they didn't really go deep into all these things. So you understand. So not to talk of the cloud professional level, but those that are going to still be doing the exam. Just know what EMR is. You understand? Just know what it is. Think of big data. Think of elastic map reduce. So you understand. So how it works, data can be stored in Amazon S3 or other data source. Data processing, you can run jobs using frameworks like Hadoop for batch processing or Spark for real-time analytics. So the job submission, users submit job via the AWS Management Console, CLI, or SDKs. So who can tell me what this SDK means? Who can tell me the full meaning of SDK? Who can tell me the full meaning of SDK? Quickly. Anybody? Anybody? Let me quickly type it. Okay. Anybody? Going. 1, 2, and 3. What's the full meaning of I wanted to say it. SDKs. Oh, Chidera software development kits. That's it. That's it. With the S. Yes, with the S there. With the S now. Remember, these are ways we interact with AWS services. Please, let's know this. This ones are key. So let's move on. So benefits of using Amazon EMR. So every AWS services. Scalability, easily scales up or down based on your needs. Is always cost effective. Pay only for the resources you use. Is always flexible. Support various data processing frameworks and programming languages. So the fourth one is integration. Every AWS services integrates well with other AWS services. So let's move to the last guy of the day. Somebody say Amazon QuickSight. Amazon QuickSight. So now this is the last slide. I know I was pulling our legs when I said about 50 slides. Don't mind me. The slides are not much. Just about how many remain now? 1, 2, 3, 4. Okay. It will. Okay, that's all. But before we come into Amazon QuickSight, is there any question? Maybe you heard something. Sorry. Maybe you heard something. Maybe you heard something that was not really understanding, or you are not really getting some things, or you want me to explain before I move on to Amazon QuickSight. Can you quickly just draw my attention back, please? Yeah, the network is really slow. Can we fly? Heat is much. Hello? Hello? Any question? Is it entering? Is it entering? Can we fly? So guys, let's don't give up. And trust us. We are strong ladies. Okay? Okay. Should I proceed or I should take the questions? And I believe the question is on EMR here. So I believe the question is just on EMR. That's Levina and Olushola. If I'm correct, just let me just type EMR there. If your question is on EMR, and I'll go back to it again, just type EMR, Olushola and Levina. Just type EMR. So I know it's EMR. And if it's not EMR, can you drop your question? Let me see if it's something I can quickly address. Okay. EMR. Don't mind that guy. Let's touch it again. So when we are talking about EMR, think of large data sets. Now, EMR helps simplifies big data. Now, how does it do it? It uses open source tools. Now, there are tools that helps with simplifying these big data. Example of these tools are Aperture, Hadoop, and Spark. So, EMR uses these open source tools. You get it now? To simplify this big data. When we say open source tools, it means these tools are not process first. Levina, I don't seem to understand your language. So just know these tools are not Amazon owned, but Amazon EMR helps simplifies big data using these open source tools. Aperture Hadoop and Spark. So it enables you to process large. How can you process large? How can you process large data sets quickly you use EMR, Elastic Map Reduce. Now, so it's a powerful tool for processing large data sets in the cloud. Like we all know, it integrates with other AWS services. Every AWS services integrates well with other AWS services. Now, what is big data? When we talk of EMR, we are actually talking about big data. So it refers to extremely large data sets that are difficult to process using traditional data processing tool. With the help of EMR, it makes life easy, manage and analyzes these data sets for you. Now let's look at the core components of EMR. So we have the clusters, just like when we're talking about Redshift. But in this case, we have some other ones. We have the master node, we have the core nodes, and the task mode. Now, just, like I said, we just need an overview of these. We just need an overview of what is. So the cluster is a collection of security keys. No, now. What is security? Diary of a bread of a border. What is security keys? Hey, diary of a broad Africa. You the carriers go where we no know. And what's security keys? Okay, maybe see type well. Yeah, you see that's it now. Amazon Redshift is a data warehouse. That's what I was trying to explain data warehouse. Large data sets. Which example can I use? So data sets that are extremely large. You understand? Amazon Redshift, like I said, the data in Amazon Redshift can still be organized. But when we talk about large data sets, think EMR is totally different from a warehouse. You know when I was trying to explain storage too, you understand? Redshift is a warehouse. Hmm? Data sets that are difficult to process. It's faster. Even there's data set when we talk about data sets that are big, that are difficult to process. You understand? Lots of data set. This not some most of these data sets are not organized. We will do when we can we do hands-on? Maybe we'll do hands-on. Maybe. We're going to see how it works. But there are two different things. Data warehouse is different, like from the explanation that I gave all through when I was trying to explain a Redshift. Understand? As a data warehouse, it's different compared to EMR. Exactly, it's like a data warehouse building. You understand? But when we talk about large data set, there are no specific structure of these data sets. You understand? They are just voluminous. So you understand? Hmm? Big datas. So let's proceed. I believe Olushola, I didn't hear from you again. Hope is entering. Or are you trying to digest it? Now it has entered. That's good. That's good. That's good. So, like I said, the core components are clusters. So when we start thinking of big data, so there are things, compute nodes that helps do this processing. And trust me, it's a lot. It's a lot, lots of compute node. So you can see the core components of EMR. So how it works is data can be stored in Amazon S3 or other data sources. So data processing, so you can run job using frameworks. Now these frameworks are the ones, the Hadoop, and the Spark are the ones used to run these jobs, to work on the data sets. Hmm? So let's fly. We all know benefit of using is scalability, cost effective, and the rest of them. So let's talk about this last guy now. And I believe we are all here. So Amazon quick sites from the word sites, quick sites. We're talking about visualization. Oh, that's good. You're welcome. All we need to Amazon quick site. How can I see my data? How can I even see what is going on? You understand? With my data. So with the help of Amazon, think of Amazon quick sites, like the guy that reviews everything that's going on with your data. You know how the data are increasing, how the numbers are decreasing, the flow of the data, everything. Amazon quick sites helps you. So you understand. So let's proceed now. Amazon QuickSight is a cloud-based BI service that enables you to visualize and analyze your data easily. So it helps organizations turn their data into insightful reports and dashboards. So data is beautiful, but then how can data be beautiful if you cannot make use of your data? If you can't see your data, you understand? You can't see the flow that is going on in your data. So with the help of Amazon QuickSight, you can easily visualize your data and even analyze the data. So it's user-friendly design and integration with AWS services that make it an excellent choice for organizations looking to leverage their data for better decision making. Hmm? So let's see. What is BI? So it involves analyzing data to make informed business decision. Take note of that. QuickSight simplifies this process through powerful visualization. You already have these data. How can you analyze the data and see these data? So main features: data visualization, create interactive chart, graphs, different types of ways you can see format you can place your data, like into graphs, charts, and dashboards to represent your data visually. So data sources, QuickSight connects to various data sources, including Amazon S3. We are going to do a project on a project using QuickSight. So don't worry, guys. We will understand. So the another main feature is spies. Now, spies, QuickSight uses a super fast in-memory engine called spies. It's an in-memory calculation engine. So to quickly analyze your data, we get it. So for you to quickly analyze your data, to quickly calculate you want to is a calculation engine that helps you. Trust me, when they say super fast, it's really fast. And when we're going to be doing the hands-on, the project, you are going to see how QuickSight, this feature in QuickSight helps us to calculate our data. So how it works: connect to data, import data from supported sources, create visualization, and you can share your insights, share your reports and dashboard with teams and members. Hmm? So I believe uh, that's all. So for that, the other is just benefit of using Amazon QuickSight and use cases. If there's something you don't understand here, can I get a come back again, or can I get a fly? Can I get a fly if you understand Amazon QuickSight? Or if you would like me to go back again, can I get a comeback? Hello? 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 Olushola, Levina, Miracle, Niyilola, okay? So what comes to your mind when you hear of Amazon QuickSight? There's this data, you understand, that we have somewhere, maybe in an Amazon S3 or anywhere in any storage. But how can I see this data? How can I know and make use of this data? You understand? Know what the data is and make use of this data. Think Amazon QuickSight. So with the help of Amazon QuickSight, you can visualize your data, analyze the data. You understand? It also integrates with other AWS services. So how this works now, I'm trying to rephrase it again, is you already have your data in a storage. That's just it. So using, don't let me use technical terms, but you have to connect your Amazon QuickSight to your S3 buckets. There has to be a connection. So once they are connected, then you can have access. Think of Amazon QuickSight like an eye, or think of it like a dashboard, or think of it like a big screen. Yes, think of it like a big screen. Now, the wire is connected, or there's a pipe behind the big screen that is connected to the storage where your data are. So once you just on the TV like this, you start seeing everything in your data, every data in your storage. So think of Amazon QuickSight. Just can we just imagine this together? Think of Amazon QuickSight like a big screen. You get it, a big screen, and the TV is off. But then you're not thinking, how can I see my data? I know data are stored inside this Amazon S3. How can I make good use of this data? How can I even make a good use of this data if you cannot see the data? You understand? Just like you are going somewhere and you can't see where you're going. You understand? So the same thing, the data are in this Amazon S3 bucket. But then how exactly? Oh, Miracle, you're always catching this concept. So how can you see this data? So think of a big screen. Now the television is off. Now you now have a host or something connected to the TV, from the TV inside your store. Yes, let's do a store now. You understand? A store now, and the pipe is connected there, and you have so many goods you don't know. So once the TV, now the Amazon QuickSight, is connected to the store, once you on the TV like this, that's it. You can sorry, analyze every data or everything inside your store. So you don't need to go there and be wearing nose masks and start searching for things. It can take a long time. So you get it now. So think of Amazon QuickSight like that. So it helps you. There's actually a dashboard where you can actually see everything, how the data is flowing. So you can choose any type of charts you want. So you can choose graphs. You can choose. There are different types. They're countless. So you get. So just think of Amazon QuickSight. Just how can I visualize my data? Have a lot data. How can I visualize it? How can I know what to do with my data if I cannot even see it? These data are much, but then I need a way to visualize this data. So, Nigelola, with this viewpoint of mine, I hope I'm able to convince you and Gloria and every other person. Hmm? Or am I too fast? Or oh, can I get a fly now? Can I get a fly? Okay. I need some refilling, As I'm speaking, strength is going out, strength is going out, something that can um help me. So let's proceed now. Let's proceed now. Okay. So let's see. So let's see the benefits of using Amazon QuickSight and use cases. So the benefits of using Amazon QuickSight: ease of use, intuitive interface, makes it accessible for non-technical users. You see now, I tried. Oh, thank you. Thank you. Thank you. I tried. Now, so it's easy to use. Even people that don't really understand technical things. So with the speaking tongues, don't worry. I'm in the spirit. I'm speaking in tongues once. So let's proceed now. So it's cost effective. Okay. All this grammar sometimes it's cost effective. So it's a per session pricing. Pay per session pricing allows you to control cost, scalability. We all know integrate every AWS service integrates well with other AWS service. You get it now. Hmm? So use cases, sales reporting, analyze sales data to track performance, customer insights, understand customer behavior and preferences, operational dashboard, monitor key business metrics in real time. So it's very simple. Hmm? Trust me, guys, once you can go, I believe I'm even able to convince us, and you understand. I've been able to make us understand these three wonderful AWS services. Hmm? So, are we good to go? Any question? Any question? Any question? Any question? Is it a network or you guys just freezed on me, Mr. Moses? Any knowledge check? No, there's no knowledge check for today because I was thinking I won't be able to cover everything. So there's no knowledge check. Yeah. So I believe you ladies already understands everything. Hmm? So, okay. So let's call it a day. Let's call it a day. Okay, let's call it a day. That's all. There's no more slides. There are no more slides. Okay. Hope some of you are not eating while I've not while we are still working here. Some of you are not using one hand to take a by one hand and using your left hand to hold your phone to watch what's going on. Okay. So that's it for today. So during the okay during the on the week we are going to send us quiz that we're going to answer of all the AWS services we've covered today. So no knowledge check today. When is our next quiz? We send that across to us. There's no knowledge check for today. I wanted to add knowledge check, but then I don't want to overwhelm us because I we our intention was just to cover Amazon Redshift, but then just so we could. I caught you. I was in the spirit, but there I know. I know. I just saw somebody holding phone. I was saying Obadara, Obadara. I was trying to pick in Obadara. But see, let me see. The person hold phone, the left hand, and was using the right hand to, do justice to the Eba. So thank you guys for today. Thank you. Thank you. Thank you. Hope you enjoyed Monday's class. Wednesday's class that was handled by uh, a wonderful colleague, and today's class. Okay, see you guys on Monday. See you guys on Monday. So don't forget to um, check your LMS platform and your Telegram. So let's call it today. Have a good night rest. Bye.